All right, folks, I am going to go through that example that I was telling you about in class. This will be kind of like your homework that you'll find on WebAssign. So, right here, we've got a table with a contingency table and information here about some data saying about the Myers-Briggs personality preferences for a random sample of 406 people in different professions there. We can see that the professions are clergy, medical doctors, and lawyers. And then, so that's our one variable. Here is the occupation, the profession that these individuals are in. And then the other variable is the personality type, whether they're extroverted or introverted. Okay, so these are our cells here. These are observed frequencies. And so the first thing that we're going to do is can I pause this recording? 1 second. All right, what we're going to do is we need to find out what our level of significance is, which is right here. So alpha is 0.05. And then we need to determine what our hypotheses are, okay? So our null hypothesis is that the Myers-Briggs, which I'm just going to do MB, the Myers-Briggs personality type, we'll say personality preference, and the profession, selected professions, whether it's the clergy, medical doctor, or lawyer, are independent. And our alternate hypothesis is essentially the exact same thing, so I'm just going to do quotations, are not independent. All right, so we're going to test this right here using our chi-square distribution. So what we need to do is we need to find our chi-squared test statistic, which is derived from the sum of your observed frequencies minus your expected frequency squared divided by your E there, your expected. So I'm going to go to the next slide. We'll have the same table here. All right. Now, this is going to take a little bit of work here. All right. So I've got these different cells here. I've got 58, 49, 71, 91, 52, and 85. 6 cells here. Cell number 1. I guess what I'm going to do is I'm going to make a table here. But first of all, I'm going to compute E. Now remember, E, and I'll put the little formula up here, is your row total times your column total divided by your sample size. So I need to do that for each one of these 6 cells. So the first one here for 58, all right, for 58, what I will do is I will do 107, all right, times 181, because that's where they intersect here at 58, times 181, and I will divide that by 406, all right? And then that equals 47.702. All right, so that's for cell number 1. For cell number 2, I'm going to do the same type of deal here. All right, so I'm going to do, and I'm going to erase this now. I am going to do, at this time, 107 times 225. And divide that by 406. All right. I am going to pause this for one moment. All right, good. We'll go back to this. Just making sure we're still recording here. And then this is equal to, or approximately equal to, 59.298. So just use your calculator here to do that, times that, divided by 406. So I'm going to kind of work a little faster here, all right, to compute all of the other ones, all right, because I need to now compute it for the third cell there, and I guess I'll do a different color. So here for 71, okay, 71, my column total is 181, my row total is 162. So E is going to equal 162 times 181 divided by 406. And that is approximately, I guess I should use some approximate symbols there, but that's okay. That is equal to 72.2217. Okay. Now I'm going to do it for this 91. Now 91 here is intersected by 225 and 162 for the totals for the column and the row. So E in this case is 162 times 225 divided by 406, which is equal to 89.7783. All right, so my homework's going to ask for 3 decimal places. That's why I've been doing 4 here. And now I just need to find E for the last row. And I guess I'll change my color to green. Okay, so for here at 52, I'm looking at my row total of 137 and 181. So expected frequency will be 137 times 181 divided by 406, and then that will equal 61.0764. All right, and then I do the same thing for 85, 137 and 225. All right, you probably get the drift now. I'm going to move a little bit faster. 225 divided by 406, and that is equal to 75.9236. All right. So, all right, now what I need to do is I need to, let's see here. All right. I am needing to remember overall, we're looking for our chi-squared. Chi-squared is the sum of O minus E squared all over E. Now, the way I'm going to figure this out is I am going to use a table here, okay? So on my first column will be O, my second column will be E. And I'm going to have a third, fourth, etc. Okay? My O column is simply my observed frequencies. 58, 49, 71, 91, 52, and 85, okay? Now E, we just computed all the way over here, so I'm just gonna transfer all of those numbers here for my column for E. 47.702, 59.298, 72.2217, 89.7783. This one is 61.0764 and 75.9236. That is all of these numbers here, these red, blue, and green numbers. I just transferred them to here. Now what I'm going to do is I'm going to compute this column here, O minus E, all right? Now O minus E, I'm just taking 58, and I'm subtracting 47.702, and I've computed this already. So this is going to be then 10.298. Right here, when I subtract, I'm just doing 49 minus 59.298. All right. And I'm going to get negative 10.298. When I do 71 minus 72, I'm going to get negative 1.2217. When I do 91 minus 89, I'm going to get 1.2217. I've already calculated this beforehand, so you all, when you're doing your homework, it might not go as quickly, but you might find some places where you can go a little bit faster. And then this one is positive 9.0764, okay? So that is the column when I did that minus that, 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 that minus that. Now my next column is this, O minus E squared, okay? Now the reason why I'm moving towards this way is because you see here, my chi-squared sample test statistic is the summation of O minus E squared divided by E. So what I've been doing is kind of getting each little thing. Here I'm gonna get the numerator of my fraction, okay? And so in doing this, I'm just taking 10.298 and I'm squaring it. So I put take my calculator, 10.298, and squared it, and I got 106.049, okay? And this one's gonna be the same, it's just negative. This one right down here is 1.49255. Guess I kept 5 decimal places there. You should be fine if you just keep 4. This one happens to be the same thing, which makes sense because they're all based on the same numbers. And this one is 82 when I do negative 9 squared, 0.381. And this one right here is 82.381, okay? Now I keep on moving over here. All right. Then my final column here for my table is going to be O minus E squared divided by E. All right. So that way I get this big old lump sum for each cell. And that's by just taking this number right here. And let me just get a highlighter. And that's taking this, and I'm dividing it by the corresponding 47.702. All right, so just take your calculator, do that divided by 47, and I end up with 2.22316. All right, and I do the same thing. I'm going to do 106.049 divided by 59.298, okay? And that will yield 1.78841. All right, I guess I'll highlight that one as well so that we can see what we divided. 106.049 divided by E, 59.298. This next one I'm going to do 1.49255 divided by 72.2217. All right, and I don't think I'm going to highlight anymore. I'm just going to write down all the numbers, but it's that divided by 72. So this is going to be a really small number, 0.02066. Okay, I guess I'm using more than, even I think there's one more 6. I'm using more than 4 decimal places. I used 6 of them there. That's okay. You can just use 4. 0.016625. All right, and then this one is 1.34882. And then the last one is 1.08505. All right. Now, this is very important, okay? Now this, remember these were just getting from doing this divided by that column, all right? Now, I need the sum. So all I'm going to do then is I'm going to add this entire column, okay? And in adding all of that entire color or that column here, okay? That will yield this. That is going to be this added with this, added with this, added with this, added with this, added with that, okay? So in doing that, when I add those all together, I get 6.4827, okay? That is what chi squared is equal to, which is the sum of O minus E squared divided by E. That is equal to 6.4827. That is the brunt of these homework assignments, is coming up with this. Okay, so we haven't had an example where we've had to do all of this yet. We didn't do anything in class today with that. But now we have our test statistic, okay? So I'm gonna go to the next page here so that I can have some more space to work with. Once we get that, it's a lot quicker here, okay? So in summary, I'm gonna write what our test statistic was. Chi squared is equal to, what did we get? 6.4827. So now I need to determine what my degrees of freedom are, okay? Now, my degrees of freedom is equal to, remember, row minus 1 times column minus 1, which is just going to equal, I have 3 rows here. So 3 minus 1, I have 2 columns, E and I. 2 minus 1, which is simply 2. That's a very simple little equation to simplify. So that's what my degrees of freedom are. Degrees of freedom is 2. All right. Now I need to determine what my p-value is. Okay. So what I want you to do is I want you to look in your book. Okay. Look in your book like we did in class today. Look in your book. When you look at your book with the degrees of freedom equal to 2, all right, and chi squared is 6.4827, you will end up with a p-value. All right. Your p-value is going to be this range here. 0.050 is your high mark. Yes. And your low mark is 0.025. That is where my p-value is, okay? Now I'm going to bring back what alpha was. Alpha was 0.05. All right? So chi squared is 6.4827. That's my test statistic, okay? So maybe I'll just write that right here. If we're wondering what our test statistic is, it is this. It is chi squared equals 6.487. My alpha is this. We got our p-value to be this based on our test statistic and our degrees of freedom. Therefore, if I was to look at my little curve here, chi-square distribution, it's going to go whoop. All right. And so if degrees of freedom is 2 there, all right, right here is probably somewhere where I have 6.4827. That's what chi squared is. And this shaded area that I've just done is corresponding to our p-value. That is what our distribution would look like. All right. Now it's time to interpret, or to conclude our test and interpret it. Okay. So this right here, is telling me, and I'm going to change my color because it's important, that p-value is less than or equal to alpha, okay? My p-value, if it's smaller than 0.05 and my alpha is 0.05, then your p-value is less than or equal to alpha. We've been doing that a lot in the past. So what does that tell me? This tells me that I reject my null hypothesis, okay? So therefore, concluding the test, we reject the null hypothesis. We accept the alternate hypothesis, which was saying that they are not independent. So in terms of interpreting this into the context of our application, I'm going to change my color again. All right, interpretation is this. Interpretation. These are the fancy words we could use. At the 5% level of significance, there is sufficient evidence, okay, to conclude the Myers-Briggs personality preference and different professions. And remember, these professions were clergy, lawyers, doctors, and professions are not independent. All right, so what this is telling us is that there is some kind of relationship. They are independent, they are dependent in some way. There's a connection between the two of them. So all of this right here, we've used some fancy words here, sufficient evidence, etc. Our data is statistically significant because we rejected and we've changed things and we've accepted our alternate hypothesis. So WebAssign is on the internet. Go ahead and work on that. We'll do the rest of 10-1 on Thursday. I hope you guys enjoy your day. That is all.